Gotta say, I'm not a big fan of this question. I went off on the wrong tangent. Somehow I seem to get the right answer. I'm not quite sure why. I did this a little while ago, in fact. But it comes down to knowing Pythagorean triples of right angled triangles. And I would say, like, know your 3, 4, 5, 1, but I feel like we shouldn't be penalized if we don't. Although you could argue that you could figure it out in the question. So, anyway, let me talk through it. Let's look at the hypotenuse to start with. This series, now if I just take the first term in this series, I'd get 1. If I add the first two, I'd get 4. If I add the first three, I'd get 9. And what I'm actually creating are the square numbers. You have to recognize that this summation gives you the square numbers. And it's not a surprise why, because look, we've got 1, and then if I add 3, I create a 2 by 2 square. If I add another 5, I create a 3 by 3 square. So it's actually going to be the number of terms squared that's going to give me the answer. For example, 7 is the fourth term. I'm going to get 16. I'm going to get 4 squared from it. So if I square root, I get back to 4. Now, the nth term of this sequence, 1, 3, 5, 7, is actually 2n minus 1. So if I want to know the number of terms, I can set that equal to the last term, 25. 2n is 26. N is going to be 13, which means the hypotenuse is going to be the square root of 13 squared. It's going to be 13. And I can draw that on. And now we can say, right, that's our right angle, that's 13. We can say, okay, because y is an integer and we're following the patterns, then this, actually the length is going to be um, equal to y plus 1 over 2. And the length of this one is going to be x plus 1 over 2. So I can add them on. All I've done is done a similar thing to over here, but set 2n minus 1 equal to our last values, x and y. But we've got to recognize that those are going to be whole numbers because the thing inside the square root is a square number. And so now it comes down to realizing the Pythagorean triple. And it's actually 5, 12, 13. So if you don't know it, it's going to have to try square numbers out. We've got 169 for 13 squared, and then you need to find two square numbers that add to that. And eventually you can get to 25 and 144. Those are the only two. This is like a unique Pythagorean triple with 13 as the hypotenuse. So then I can set x plus 1 over 2 equal to 5, for example, and then x is going to equal 9. And then y plus 1 over 2, I can set equal to 12. It doesn't matter. I just chose the x one to be the smaller one. It's not going to matter because we're interested in x plus y. And that means y is going to be 24 minus 1. It's going to be 23. That will give us our Pythagorean triple. And, oh, sorry, I don't know why I circled that 5. X plus y is therefore going to be 32.